Good morning, everyone, especially to our instructor, Engineer Ken Fumalvesda. We are the Group 3, the first presenter. So first, let me introduce to you the members of Group 3. We have Abila Kathleen May, Azucenas Jr. Ronald, De La Cruz Chris Dave, Duva Lloyd, Edison Nino Rosal, Fructuoso Jiminy Imo, Jordan Marshall Gabriel, Humapit Sanfree, Pacquiao Jamaica, Sumbi Rimar, Villaraisa Janisile, and your highly, Dakoma Katime. Okay, let's start our discussion now. So we are going to discuss the topic curve fitting and interpolation. For curve fitting, in Anesia, curve fitting, it is a procedure in which a mathematical formula is used to best fit a given set of data points. So, for example, we have this given data, kani ang na-stable, and then if we project it or if we graph it in here in our figure, as you can see, it is not or hindi mo siya maiilinya ng derecho, or you cannot find a line that actually encompasses all exactly. So what we do here in the curve fitting from the word itself is we would fit a curve or a line that best describes the data above. So for example, we have a scattered data. What we will do, guys, is we will make or solve for the best mathematical equation or the equation of a line that best fits the scattered data stated in the problem. For the interpolation, that is simply the estimating for a value in between two known data points. So for example, kanang naa sa ato ang figure nga makita nato sa ato ang screen, kung sa inyong nabantayan na ay dot diha nga usa nga wala pa ta kahibaw og unsay exact coordinate or coordinate ana niya nga gipatung-an sa duha ka known data points. Ang atong buhaton ana para mahibaw-an nato is mag-interpolate ta para So let's move on. So here are the some applications or useful of curve fitting and interpolation. Curve fitting examines the relationship between one or more predictors and the response variable, which is the dependent variable, with the goal of defining a best fit model of the relationship. Interpolating can turn complicated functions into much simpler ones that are easier to evaluate. So let us also distinguish between curve fitting and interpolation. Curve fitting is when you have a data set of scattered data points and find a line that best fits the general shape of the data. While the interpolation is when you have 2 points of data and want to know what a value between the two would be. Halfway between would be their average, but if you want to know only a quarter of the way between the two, you've had to interpolate.
Polynomial interpolation. A polynomial interpolation is a method of interpolation done by obtaining the lowest degree polynomial that passes through all given points. If there are n plus 1 ordered pairs in the data, the lowest degree of the polynomial that can connect to these points is n. For example, a data of 4 pairs can be connected by a polynomial to the third degree. So, interpolation using polynomial functions is a technique for estimating values between known data points. When graphical data contains a gap, but data on each side of the gap or at a few specific places within the gap is accessible, interpolation can be used to estimate the values within the gap. And the most straightforward way of interpolation is to draw straight lines between known data points and consider the function to be a composite of those straight lines. This technique, referred to as linear interpolation, frequently introduces a significant amount of error. A more exact technique connects the points using a polynomial function. A polynomial function is a mathematical expression that consists of a series of words, each of which contains a variable or variables raised to a power and multiplied by a coefficient. Polynomials with a single variable are called simple polynomials. Polynomials can be factored or expressed in their entirety. So the main problem with polynomial interpolation arises from the fact that even when a certain polynomial function passes through all known data points, the resulting graph might not reflect the actual state of affairs. It is possible that a polynomial function, although accurate at specific points, will differ wildly from the true values at some regions between those points. This problem most often arises when spikes or dips occur in a graph, reflecting unusual or unexpected events in a real-world situation. Such anomalies are not reflected in a simple polynomial function, which, even though it might make perfect mathematical sense, cannot take into account the chaotic nature of events in the physical universe.
So let's proceed to the example. Determine the value of f of 7 for a given set of data below using polynomial interpolation. As we can see the given data below, we have data of x and f of x, and we are gonna use this data to get the value of f of 7. Solution. The given data set has 4 ordered pairs. It means that the lowest degree of polynomial that can connect these points is 4 minus 1 equals to 3. So we have given nga 4 ordered pairs, so therefore minusan na nato og 1, then we have a degree of 3. The general formula for a third degree polynomial is f of x equals ax cubed plus bx squared plus cx plus d. So ang goal ani is to create a linear system of 4 because we have 4 unknowns which are the a, b, c, and d. So to solve the first pair which kining 1 and 12, ato ra ni siyang i-substitute sa general formula nga f of x equals ax cubed plus bx squared plus cx plus d. So substitute, then solve. Then that is our equation 1 nga a plus b plus c plus d equals 12. For second pair nga 5 and negative 26, same process Japon, substitute, then solve. Then we get our second equation nga 125a plus 25b plus 5c plus d equals negative 26. And also for third pair and fourth pair, still same process, substitute, then solve, and our equation 3 is 512a plus 64b plus 8c plus d equals negative 14, and equation 4 is 1000a plus 100b plus 10c plus d equals 37. So after we established our 4 equations, all we need to do is to solve these equations using Gauss elimination, or if you have a calculator that is capable to solve equation for unknowns, and that is good. So after solving our 4 equations, we got our value of a, b, c, and d. So the value of a, b, c, and d, we will substitute it again sa general formula. So this is the f of x equals 0.2634921x cubed minus 1.760317 squared minus 7.1063492x plus 20.603176. Then solve the f of 7 using the polynomial. Substitute again, then we get the value of f of 7 nga negative 25.019037. So this is the graph. We can see the given points, then the green broken line na curve, it is the interpolation curve, then the orange is the interpolated point.